continuous mechanical, we can call it whatever you want to call it. Okay, but we are going to talk about a controlled mode, which means either volume controlled or it could be pressure controlled. All right. So now let's go to how it looks like. Okay, now I'm going to tell you about trigger, I'm going to tell you about limit, I'm going to tell you about cycle. These waveforms may not look like this on the ventilator, they are different. But this is a basic understanding of what the waveforms are all about. Alright, so you have flow, you have pressure and you have volume. Each ventilator will have a flow, will have a pressure, will have a volume. Flow, pressure and volume, these are three things that will be there. You will have flow, you will have pressure, you will have volume. You will have these waveforms on all your ventilators. If you don't have these waveforms, means your ventilators aren't really giving you the the numbers properly. Right? Now, in this flow, pressure and volume, now when we talk about volume control, or for that matter, control mode of ventilation, I'll explain to you the first mode, trigger. Now here when I'm saying controlled mode, I'm not really dependent on patient's trigger at all. Okay, if the patient triggers, I need to have a negative pressure, isn't it? We discussed what is spontaneous mode. When a patient triggers, when the patient is breathing on his own and goes into negative pressure. Right? So if the patient triggers, I must see a negative deflection. So the trigger, if the patient is having, it will be a negative deflection. Okay? We'll come to different types of triggers and all, but it will be kind of a deflection at the start of the pressure waveform. It will be a deflection at the start of the pressure waveform. So do you see a deflection at the start of the pressure waveform? No. We don't see a deflection in the start of the pressure waveform. So what kind of trigger is this? This is machine trigger. Okay. Or you could say time trigger. You could say time trigger. That means I set a respiratory rate of 10 in a 60 breath window, in a 60 second breath window. I am saying give 10 breaths. That means every 6 seconds is the breath cycle. In that 6 seconds of breath cycle, I have decided to keep an I ratio of 1:2. Okay. So if I have a 6 second breath cycle, 1:2 means 2 seconds will be inspiration and 4 seconds will be expiration. So let me put this over here. So you have 2 seconds in inspiration and 4 seconds of expiration. Understood this much? Simple? Is this simple now? Alright. So now, when I am saying trigger is the patient, trigger is the ventilator. So what is happening is, at the start, here is where the machine is giving the breath. The machine starts giving the breath, and whatever type breath it may be, stops, cycles from here. Then it waits for the next cycle to start and gives the next breath. So it's time triggered. It is triggered by time. Patient is not doing anything. Okay, it is the machine that is doing it. So machine or time triggered. Machine, time triggered. You understand? The machine is doing everything. Clear on this? Time triggered breath. Right? Clear on this? Now, we did talk about TLC. L is limit. Right? L is limit. So how is the breath limited? How is the inspiration limited? That is the query that we are asking. How is the pressure? Is there anything that is limiting in my inspiration? Now, we have started a flow inside. Okay. Now what is happening over here? There is a control that has happened over here. It is limited. It's not allowing you to go higher than this. Since it's not allowing you to go higher than this, okay, it is limited this at this pressure. It's limited this is pressure. So what is the limit here? What is the limit here? Pressure. Okay, and what is the cycling over here? Time. Because we set the I ratio as 1:2, and we said that at the end of 6 seconds, at the end of 2 seconds, go into expiration. So that's why the cycling is time cycled. Clear? Simple? As we go, we'll understand. Now what is assist control? The word assist means now I am delivering some amount of assistance and patient can assist this kind of breath. Okay, so in this case, the trigger would actually be by the patient. That is what is assist control. If the patient doesn't trigger, it will be time triggered. If the patient doesn't trigger, it will be time triggered. Simple? So what is going to happen in assist control? This was the waveform that we had. We had the flow waveform. I just moved the pressure waveform here. The pressure waveform. The pressure waveform, what is going to happen here for the trigger? Then if it is a pressure triggered breath and the patient is initiating, there would be a small deflection. So now what kind of trigger is this?
This one is
patient trigger. Forget about whether it is flow or pressure or whatever. This is patient trigger. Okay, this is patient trigger, and then you have variable pressures. No, you have one pressure here, one pressure here, one pressure here, one pressure here. So the pressure is varying. Pressure is varying, but what is happening? The volume is constant. The volume is constant. Since the pressure is varying, it is here it is one pressure, here it is one pressure, here it is one pressure. Whereas the volume is actually remaining constant. At the end, volume is remaining constant. So this is called as volume limited and cycled by. And what is the variable?
pressure.
So how would I describe this mode on my TLC? So when I say any TLC, that is trigger limit and cycle, I would say TLC and variable. TLC variable. So triggered by
patient.
Triggered by patient.
Limited by triggered by patient, limited by volume,
Yeah.
and cycled by flow.
No.
Time.
Cycled by time. Why?
So because of time, so because of the IE ratio.
Yeah. So what has happened is I've set this has 6 seconds because it's a 10-second breath, and I've set an IE ratio. So the moment it reaches 2 seconds, it actually goes into expiration. So it is time cycled. Cycling means conversion from inspiratory phase to expiratory phase. That is cycling. Okay. So this is how I would talk about assist control. This means to say that in this mode, if the patient's respiratory rate is, you have set a respirator of 10, and the patient takes 20, what is going to happen? Say in assist control, I have set assist control where my RR or frequency I have set as 10, but the patient is breathing 20. Patient is taking 20. So what is going to happen to this patient? This is assist control mode. I am repeating this question. Patient is in assist control mode. Patients, you have set a respiratory rate of 10, but the patient is breathing 20 times. For example, he is acidotic. He is almost triggering the ventilator, maybe 20 patients' breaths are coming. What is going to happen?
That huge amount will be delivered, sir.
What would happen to the breath?
CO2 also.
What would happen to the breath? Forget about what's going to happen to the patient. So if the patient triggers 20 times, what kind of breath will be delivered?
You will take constant volume.
So he says constant. What about you, Nikhil?
Yes, sir. We also said it is volume limited.
What will happen? So this means to say you are saying that if the patient takes 10 breaths, you have set 10 breaths of 500 ml tidal volume. If he takes 20, he will get 20 of 500 volume. Is it like that? You understand what I'm asking you, right? Because you limited the volume to 500. You limited the volume to 500, and you've told the patient you have set a respiratory rate, mandatory respiratory rate of 10. Now patient takes 20. Is he going to get 10 into 500, and when he goes to 20, gets 20 into 500?
So those which are patient triggered breath will be there. Mandatory breath will be delivered for above 500, but others will tidal volume will vary.
No, so that's not the answer.
Same
The answer is it will be the same volume delivered again and again. Same volume. So this means to say, if a volume controlled patient on this starts breathing excessively acidotic, becomes acidotic, he will get all the breaths to be assisted and limited at 500 ml. So his minute ventilation will go from normal 5 liters to 10 liters. Clear? This is what is going to happen in assist control. Clear on this? In any kind of assist control, let it be pressure, let it be volume. In any kind of assist control, this is what is going to occur. So a patient getting into respiratory alkalosis is very high if you do not control the basic pathology with which the patient has come in. Clear? Clear on this? Clear on this? So another pressure triggered breath and pressure variable trigger limit cycle. Clear? Now let's look what happens to SIMP. Synchronized intermittent mandatory ventilation. So when assist control came in, see the first thing that came was control mandatory ventilation. Then the second thing that came in was, what was happening, initially how this all modes came was, initially when you have controlled mechanical ventilation, has anyone worked with Manley ventilators? Okay, so you all wouldn't have worked. We worked with Manley ventilators. Manley ventilators is like an ambu bag. Okay, what happens with the Manley ventilator is, the ventilator just gives a breath and nothing else. Just gives like an ambu bag. like an ambu bag, it's got a kind of a bellow. Ventilator chop, it just works like that, and just air from outside or oxygen attached to the will go inside the patient. So what happens in that is, irrespective of where the patient is, whether the patient is trying to breathe, whether the patient is taking a breath, whether the patient is expiring, irrespective of what is happening, this keeps on going on like a machine. It just keeps on going. There is no synchronization at all. Okay, there is nothing at all. Okay, this was what the initial thinking was. This means to say, I have to look at the patient to understand whether what I must do with the ventilator. Even if I reduce my respiratory rate there, if I make my respiratory rate from 20 to 10, even if the patient is breathing in or breathing out, nothing is going to happen. It is going to just give 10. If the patient is trying to expire, he can't expire because the valves are closed. Because the valves are closed, he can't expire. If he wants to take a breath and the ventilator is not in that mode of giving the breath, he cannot take a breath. Are you understanding? Valves were not opening. Clear? So what did they do? In that phase, they created a phase where the valves could open irrespective of what mode the patient is on. So that is the birth of SIMV. So what happened over here? Till now, if SIMV was not there, if the patient was trying to breathe in this mode, the ventilator will not help it. It will in fact harm it. You try to breathe, the valve is closed. Try to breathe, the valve is closed. What it has done now is that it has made one phase in the middle where the valves open up. This means to say, in the earlier breath you saw there was mandatory ventilation. So now in the middle, if the patient tries to breathe somewhere there, say for example here, if I say this phase and I have the patient wants to breathe somewhere here, it cannot do anything here. If it wants to take an inspiration here, it cannot get an inspiration. In control, forget this trigger. In a control mode, okay, patient cannot take it. That was what the situation was. Now what has happened is, in this kind of mode, it has clear on this? So till now what was happening, that like an ambu bag, tuck, it was just giving it. If the patient is breathing or not breathing, it doesn't matter. Okay, if the patient wants to breathe out, it cannot, because the ventilator is not allowing, all the valves are closed. What is happening actually? In inspiration, the valves are opening, patient is getting the breath. During the breath, after the breath, the valves are closing. The breath, whatever happens, the patient cannot inspire or cannot expire because the valves are closed down. Right? Now what they did, they put one phase in the middle. Somewhere in the middle, they put one phase where whatever the patient is doing, patient can do. That is what the birth of SIMV was, along with the trigger. So trigger came first. Then with the trigger, they put a place where you could actually breathe in the middle. That is the birth of SIMV. Clear? So this is, you understand now what's happening here? So I have some pictures of what the early ventilators were, also history, I can show it to you sometime later, but this you must understand. So now what is happening is, there is a mandatory period, this is a mandatory period, and this is a patient period. So there is a mandatory period of breath, and there is a free period or the SIMV period. Okay, so इसमें क्या हो रहा है? बीच में patient can breathe, he can inspire, he can expire. That's why it's going inspire, expire. The patient can do what it wants to do. This is SIMV. It was thought of that, that if I reduce the problem was when I'm weaning my other patient, there was no way that I could wean the patient by reducing the rate. Because even if I reduce my rate, the patient cannot breathe because the valves are not open. Now what is happening is, when I'm reducing my SIMV mandatory breath rate, I'm reducing, there is place in the middle for the patient to breathe. That's why this was touted as a weaning mode, SIMV. Clear? Any doubts on SIMV? Okay, so if I were to actually tell what kind of, if I put it back into trigger limit cycle, what would you say, Amit? Trigger limit cycle?
So trigger by ventilator.
Look carefully.
No, sir, your patient. Then limit.
No, patient trigger, okay.
Patient trigger. Limit by
Limit by
volume.
Limit by volume. By
Sir, because
the clue is that the volume is constant. We can see the volume being constant and the pressure being variable. So the limit is volume. That's why it's called SIMV volume control. Okay, limit is volume, and the cycling is time. Variable is pressure. Right. So this is the mandatory breath rate. Right. The other clue that you can get for exam purposes is constant flow. The other clue that you can for exam purposes, okay. Otherwise, there are ventilators in which we can actually change the flow characteristic. But for exam purposes, when this graph comes in the exams, you have to call it as volume control mode. More often than not, 90% of the ventilators, when they are on volume control mode, will deliver a constant flow wave pattern. Say constant flow. This flow remains at whatever 60 liters, so 60 liters flow is going on. It delivers a constant flow. Somewhere unlike variable pressures. Clear? More often than not, most of the ventilators, if you go to and put volume control on your machine, you will see constant flow wave pattern. Clear? In the flow wave pattern, we are seeing this to be constant flow because the ventilator is delivering the breath here. And then here you are seeing this variable because expiration is passive, ventilator is not doing anything, it is a patient that is doing it, that's why it is varying. Clear? Flow. Inspiratory flow. Expiratory flow. This is not the ventilator. This is our patient. तो जो भी पेशेंट का रिलेटेड प्रॉब्लम रहेगा वो इधर दिखेगा हम लोग को, इधर कुछ नहीं दिखेगा हम लोग को. That is why when we want to monitor peak expiratory flow rate, I'm going to look here, and as I'm nebulizing my patient and I want to see improvement in my patient, my peak expiratory flow rate will change. You understand? Clear on this? Similarly, if my patient is having extreme bronchospasm, I'll see this to be prolonged. I don't see any changes in this. I'll see changes in this, in the flow waveform. समझ में आ रहा है? Because this period is the patient period, right? So in this form of ventilation, there are two forms of ventilation. The first form is a mandatory form where you rightly said that the trigger is the patient, the limit is the volume, and the flow is the flow is constant, and the limit is cycling is the time. Variable is the
Pressure.
Now, what about this pattern? So, what is the trigger here? There is no trigger only. No? Whatever you call it patient, it's not triggering any breath only. There is no breath. Where is the ventilator giving any breath? How does the ventilator deliver the breath? Is the mode, right? How does the ventilator deliver the breath? Is the mode. Is the ventilator delivering any breath here? It is only allowing him to breathe. So there is no trigger, there is no limit, there is no cycling. There is no trigger, because the ventilator is not giving any breath. If the ventilator were to give a breath here, it will look like this. Flow will start inside. Pressure will go up. However, we have decided the volumes will go up as per what we have mandated. So in this there are two kinds of breath. One is the machine triggered breath, and the other two types of periods. One period is the mandatory period, and the other period is the SIMV period. Clear? The patient period. Got the point? Clear? There are two kinds of breaths here. Clear? Alright. Now, this is your spontaneous breaths. Okay, the spontaneous breaths the patient can do whatever the patient wants to do. Now, how this is determined, ये spontaneous इधर कैसे आ गया, इधर क्यों नहीं आया, इधर क्यों नहीं आया, इधर क्यों नहीं आया, that is dependent on each ventilator's software. Okay, that is depends on each ventilator's software. For example, what is the software in the existing ventilators that we have? We have, the breath is divided into two parts, inspiration and expiration. In inspiration, there is a SIMV period and a mandatory period. For example, I'm making it a little bit complex now. Okay, you have an SIMV period and a mandatory period. You also have to understand where to trigger. This trigger is only activating the breath, whereas this trigger is not activating the breath. This trigger is activating the breath, whereas this trigger is not activating the breath. That is what we are telling the ventilator, don't activate the breath here. We are telling the ventilator, let the patient breathe on his own with the valves open, don't activate the breath here. Now the ventilator needs to understand when to activate the breath and when not to activate the breath. So each machine has got an algorithm. Okay. Now in the algorithm of our machine, you divide them into SM. Most of the ventilators work like this, where you have a SIMV period and a mandatory period. So what it does in the inspiration, let me take this as the inspiratory phase till here. Let me take this as the inspiratory phase. That's why I started by saying inspiratory phase. Inspiratory phase doesn't mean flow is going, it's just a phase. Okay. It will wait in the inspiratory phase to a certain period. To a certain period that is a formula by different softwares. Okay. It will wait for a certain period. In this period, if the patient takes a breath here, the ventilator will give the breath. In the event that the patient does not take a breath here, it waits till here, and once it reaches here, it gives the breath. That is how it is synchronizing the patient trigger to the machine. Clear? You have an SIMV period and a mandatory period. Understood this?
If means you are saying, sir, in SIMV period, if patient triggers, then it will give breath
Yes.
for a particular period of time.
For this, whatever you have decided. You have decided to give tidal volume of 500. You decide tidal volume of 500.
Then machine will allow patient to breathe.
So this is the entire period. Once it reaches this variable,
So,
then
after inspiratory phase, if patient breathes, then machine will not trigger breath.
yeah, after the phase, it has a phase where machine will not trigger the breath because this is the period that you have set. So now, say for example, it takes this breath and comes down here. So it has given the mandatory volume of 500. That's why we are calling it limited by volume. After that, what happens? All this part is going to be patient.
In that period, it won't deliver that much volume.
It will not deliver that volume. Yeah. You understand? Huh? Clear on this? SIMV period and mandatory period. That is what you must remember. So if you want to understand, and what happens is intelligently, if say for example it breathes over here. Now some patient may breathe there and stop here. It will be a very long period. So what it does, by a software, it moves this phase variable downwards. It moves it downwards so that it doesn't really cause problem. Otherwise you might wonder, एक बार breathe कर दिया फिर बहुत बार it will not give a breath. ऐसा लगेगा ना आपको? For example, this is my mandatory period. For example, this is my SIMV period. It takes a breath here and just stops here. Then I have a very long period where it is spontaneously breathing. Patient will get tired, no? You might think like that. What happens in this ventilator intelligently? It will move this phase variable inwards. And each ventilator has got a different way to do that.
RR should then differ, sir, but we give mandatory breath, we keep it set.
Yeah, we keep that set. No, our mandatory breath that we are setting is for this breath.
Yeah, right.
Right? So, if by any chance any chance this is happening that he is breathing earlier, what you are asking me is, then if this comes here, RR will change? It will not, because intelligently it moves everything. It keeps moving it. It keeps moving it this way or that way to ensure that he gets only 10. Understanding?
Sir, how does the ventilator decide that this trigger of patient has to be given volume?
This
one trigger of the patient has to be delivered volume.
that we are going to set trigger. Trigger we are setting. That is a force. We are talking about time. When that trigger should deliver. The trigger is a completely different thing. We didn't discuss that yet as to what is the trigger at which. So this means I would set say 2 centimeters of water. Mean if I come to 2 centimeters, then this breath will be supported by a volume control. However, whether I have to do that in the first place will depend on the period.
So that SIMV period, if in that period only patient takes 2-3 breaths, then it will deliver that.
No, it will not. It will not. It will give only that one breath and stop.
Only one.
Yeah, it gives the one breath and stop. That's the difference between assist control and an SIMV.
And so once the
So the difference in assist control, and SIMV would be assist control, it took one breath, stopped, take another breath, stop, again another breath, third breath, again breath, fourth breath, again breath. Whereas SIMV, what is going to happen? You take a breath, stop, he takes a breath, allows him to take breathing, but it doesn't assist. Because it is not in the SIMV period. But if he is in the SIMV period here, and he takes one breath, then and takes one more breath, इधर एक और breath आ जाएगा.
हाँ, that will that time it will deliver.
हाँ, लेकिन वो SIMV period छोटा होता है. वो SIMV period इतना छोटा होता है कि वो वैसा होने का चांस बहुत ज्यादा कम है.
So that time when you take one breath, it will adjust here.
It will adjust it, वो adjust कर देगा वो. लेकिन वैसा होएगा नहीं. SIMV पीरियड इतना छोटा होता है ना कि वो ट्रिगर वॉल्यूम डिलीवर करते करते वो पीरियड निकल जाता है. समझ में आ रहा है? Clear? SIMV. So there are various ways to do this. If you look at the servo 900cc, we used to work with the servo 300 and 900s. For servo 300 and 900, we had to set the SIMV period ourselves. When we were doing our ventilation, we had to set this period also, which you are not doing because of the high profile microsensor chips and solenoid valves that you are having. You are not doing it. It's done on its own. We had to set that because it was all mechanical. It was not computer based. So we had to set that. We had to set that with a certain way. We used to set it. Okay. So it used to be a very catch questions in the exams. In the exams, for us, in our exams, it used to be a very catch question. How do you set the SIMV period? Because it is something that you have to understand the ventilator for. What is the scissor valve? What happens inside? We used to open the ventilator. Our ventilator was also based on open the ventilator and tell me what is wrong in the ventilator. It used to be like that for us. Because of course we had to know it. We were in the situation where we didn't have so many technicians. You understand? So understood this now? Understood? Any doubts here? Any doubts?
So any mandatory, when the breath is delivered, it will be a mandatory breath. So it will be delivered as per our settings.
That is the meaning of mandatory breath. Mandatory is what I am putting as trigger limit cycle will be for the mandatory breaths. The rest I am not setting anything. Clear? So there is a possibility that here at this stage your tidal volume is 500. At this stage tidal volume is 500. Whatever flow you have set, 60 liters per minute flow पे हो जाएगा. तो वैसा दिखेगा वो. लेकिन यहाँ पर जो ब्रेथ रहेगा एक 200 होगा, एक 100 होगा, एक 250 होगा, एक 500 होगा. अलग-अलग ब्रेथ आ जाएगा इधर. Then it will wait. Once it finishes this time, SIMV period का वेट करेगा वो. अब SIMV period चालू हो गया. SIMV period का ट्रिगर आया, चलो दे दो उसको ब्रेथ. You understand? That's how SIMV works. Okay, SIMV period. That's what you should understand. Now, we just talked about the fact that you have these breaths in the middle. You have these breaths in the middle. If I add some kind of help to this patient here, okay, I can do that. And to add that some kind of help, if I add a pressure support to this breath, okay, you will ensure, you will give an extra pressure which will help, and that is what is happening in this. This is what is happening in this. You are adding an extra pressure support. Okay, now what you must understand here, now let's go back to this mandatory breath first. This mandatory breath. What is the trigger here? Nikhil? What is the trigger?
Mandatory breath. Machine trigger.
Machine trigger. No. What is the trigger? Why are you calling it machine trigger? Why is it patient trigger?
Negative.
No, please. Let when you get the term, you can answer, please.
Negative deflection. Pressure.
Patient is initiating. Don't say negative pressure. Patient is initiating. Because otherwise, if you say negative pressure, now you will start searching for the negative pressure on the waveform. Patient is initiating. I have not said it. Okay, because as I told you, this is for your understanding that these waveforms are formed. It is not like this on the machine. It is slightly different on the machine. So what you must say? Patient is deciding when to start the breath. Okay, that is why. So that is the patient is deciding when to start the breath. This is patient triggered. ठीक है. Exam purposes से तुमको negative reflection दिख जाएगा on exam purposes. But practically, we are not here to finish our exams. Exams, all of you are going to pass. You are here that in the future when you are working, you know what you are doing. At the end of the day, all of you guys who are sitting over here are here because you are like intensive care, isn't it? ऐसा नहीं है कि भाई मेरे पास दूसरा कुछ नहीं करने के लिए इसलिए मैं कर रहा हूँ. You like intensive care, and if you don't like intensive care, then leave intensive care. Because throughout your life you have to like this subject. If you don't like this subject, then जिंदगी जिंदगी हो जाएगा. Enjoy the subject, then only you will enjoy everything. Okay. So trigger हो गया. What is the limit here?
Volume limit.
Volume, because you're seeing this volume should be the same, and the clue here is the flow being constant. Okay, cycling is time cycle, because you have decided that at this point the machine should go to expiration. This is going back to expiration. Clear? Now what is happening in the other breath, the second breath? What is it? Patient triggered, Nikhil? What is it?
Yeah.
Machine or patient triggered?
patient triggered?
Because you feel that there is a small alteration in the patient's dynamics. Because if it was mechanical breath, everything should have been positive in the pressure, right? If it was mechanical, everything should have been positive. Now, because the patient is doing something, that's why it's come negative. We discussed spontaneous, negative, mechanical, positive. Okay, so since the patient is doing something, you are seeing this small negative deflection coming over here. So that is patient triggered. You're right. What is the limit here? How do you think? What is the limit? What is the definition of limit?
It is set at some point. It doesn't change.
Yeah. So I am telling that stop the
Stop
inspiration at this particular point. Huh? That is my limit. Stop giving more flow at this particular limit. Let it be more. So what is the limit over here? What I want to hold constant here?
Pressure limit.
Pressure limited. What is it doing? It is pressure limited. That's why what is happening? Your pressure is constant. It has gone up, huh? But has remained constant. So you might wonder, "Ye aisa kyun ho gaya?" It is trying to maintain that pressure. It is trying to maintain. It went up first so that it could reach somewhere up, and then it was maintaining that at that pressure. Huh? That's why it is the flow is decelerating. It doesn't require so much of pressure. ऊपर चला गया फिर वो कम कर रहे हैं ताकि वो ये प्रेशर पे मेंटेन रहे. पहला बहुत ज्यादा प्रेशर चला गया, वो बहुत ज्यादा प्रेशर चला गया, फिर उसको मेंटेन कर रहा है. मेंटेन करने के लिए ऑब्वियसली फ्लो में कम होने वाला है बिकॉज़ ज्यादा प्रेशर अंदर चला गया. Right? So you have a set. So the limit is your pressure. What is your cycling? What is the cycling? Conversion from
inspiratory phase to expiratory phase.
that means allowing the ventilator, allowing the patient to breathe, converting from inspiration to expiration. So let us see. ये इंस्पिरेशन चल रहा है, ये एक्सपिरेशन चल रहा है, लेकिन ये तो सेट प्रेशर पे है. मतलब यहाँ टाइम हो सकता है क्या? ये टाइम less likely. What is happening over here? Something funny is it is actually cutting down here. That means in most of the ventilators, pressure supported breath is flow cycle. When I say flow cycle, means क्या हो रहा है? My flow was reaching 100%. Once it reaches 25% of my 100%, it is cycling. Once it reaches 25% of my 100% flow, this is flow waveform, this is pressure waveform, and this is volume. Okay, so in my flow, I have reached 100 flow, say for example, 100%. So it may be whatever, it may be 60, it may be 70, it may be 80. When it reaches 25% of that liters per minute, it actually cycles. So what kind of cycling is this? This is called as flow cycling. So now we have two breaths here. We have an SIMV breath and a pressure supported breath. And this all is also following the same principle that I talked about, SIMV period and patient period, right? SIMV period, mandatory period and patient period, right? So in the SIMV period, what we discussed is happening. But in the patient period, they are adding a pressure support with a different breath characteristic called as pressure supported breath, where the trigger is the patient, the limit is the pressure, and the cycle is the flow. Variable is volume, because the volume will keep on varying, pressure remains constant. So there are two breaths here. Can you tell me two breaths here? Two types of breathing.
Spontaneous.
So what kind of breathing is it? You have to, when you talk about what kind of mode is going on, trigger, limit, cycle, variable. So
This is patient triggered.
there is one breath type there are two breath types. There are two breath types. One is this breath type, other is this breath type. So what is the first breath type?
That is ventilator regulated. So that is patient triggered.
Patient triggered,
Then volume limited.
volume limited,
And time cycle.
time cycle. And the second breath is
Patient triggered.
uh,
Pressure limited.
uh,
And flow cycle.
excellent. Okay, clear on this? So you have two breathing attempts over here, right? This is what is occurring. So that's what is called as flow cycling. That's what is called as flow cycling. We have a set pressure support. We've got a set pressure support. This is all what kind of breaths? Sachin, can you tell these breaths? Tell me what kind of mode this is? When I say what kind of mode, immediately you start talking about trigger, limit, cycle, variable.
Yes.
Tell.
There is a patient trigger.
Why is it patient triggered?
Sir, since there is an initiation of breath from the
From the patient side, very good.
And sir, it is TL.
Limited by
pressure
limited by pressure, very good.
and cycle by flow.
Cycle by flow. Why you say it's cycle by flow?
So since it's coming down and
It's cutting off at a
Cutting
certain
off
flow.
the
That's why it's called as flow cycle.
Flow cycle.
What is the variable?
variable volumes.
There will be volume. Very good. So what kind of mode is this?
Pressure support.
It is a pressure supported mode. It may be called by various terminologies. For example, in the Draeger, what is it called? In the Draeger, what is it called? In the Draeger, what is it called? You have a machine over there? ASB. In our Draeger ventilator, you should know all these things. In our Draeger ventilator called as ASB. What is it called in our PV840? It's called PS. It's written over there. So remember, so don't confuse those names with these things. Understand the breath delivery and talk the same language. So in the ICU, one person should not say ASB pe rakh raha hu, one person should not say pressure support pe rakh raha hu. Everybody says the delivery of mode is trigger limit cycle is this and probable pressure. We use the same terminology. If you are using pressure support, irrespective of ASB, you say pressure support. You understand? Colloquially, don't use the machine terminologies. You know, otherwise you make this mistake. BiPAP पे डाल दिया मैंने. अरे BiPAP pressure controlled breath होता है. It is not NIV. BiPAP is pressure controlled breath. So drop that some terminology. So our terminology here will be pressure supported breath, where trigger is patient, limit is pressure, and cycle is flow. Clear? I can control this flow. I can control this trigger, but I can't control the volume. I can control my pressure. Okay, I can control my pressure. I can limit my pressure. I can control my trigger, because if I increase my trigger, make it more negative, -7, -8, patient needs to make -8 effort to trigger the ventilator. I can change my cycling. For example, I can make from 25% to 50%. What will that do? If I make it from 25% to 50%, what will it do, and where do you think we could probably use this? What will happen what will happen, Sachin, what will happen on the ventilator if I change my flow cycling from 25% to 50%? What will happen?
So that period of time, first of all, it will get shortened. So
Which period of time?
delivery of like volume,
Delivery of flow, yeah.
Flow.
Flow delivery would be
shortened.
So,
So sir, less volume will be delivered.
possibly less volume can be delivered. So in a normal person, what will happen? Is less volume will be delivered. In a normal person, this is what is going to occur. Lesser volume will deliver. You got the point? Lesser volume will deliver, because the amount of time that is going to happen is going to be cut off. Clear on this? That's about flow cycling. We may not alter this anytime. We will not want to alter this anytime. Okay? In some modes, in some ventilators, that flow cycling, it can be changed. Not in all. Our machines you can't. When the Hamilton comes, look at it. I'm getting the Hamilton tomorrow. After the machine, there's a mechanical mental workshop in Sion. After that, the machine will come here. In that, there is ETS, expiratory trigger sensitivity. You can change it. Right? So whether, when, what, let's come to that later on. It is too much high-fi for that.
So I ratio will get changed in this. If flow cycle will change.
Yeah, I ratio will change, but why, when, what, we will discuss that at a later date. Okay? But understood this flow cycling? Okay? Alright. Now, this is what is SIME pressure support. Clear? So, in the characteristic, very clearly you have a set pressure support. You have variable pressures, pressures coming. This is variable pressures because the volume is constant in the mandatory breath rate. Clear? So flow cycle. This is flow cycling at a set pressure support level. Clear? Now what is happening here? ये क्या हो रहा है? So Amit, can you tell me what's happening here? Or wait, you answer Smita.
Trigger.
So is there two breath types first? First to answer whether there are two breath types, or is it just one breath type? There are clearly two breath types. There is one breath type here, one breath type here, which is different. Now what is happening? What is the first breath type? Let's take the first one.
In the first breath type, there is trigger by the patient.
Patient trigger, okay.
Trigger. Limit is also pressure,
Why?
because the cutoff which is there from the flow. No, one second. Yeah, pressure will be the limit.
Pressure is the limit because it is going up and it is constant
Very
here.
constant.
It's limited by pressure and cycling
Cycling is time.
time. Because written also, you know, time cycle.
So that the cutoff is also there.
Okay.
Managing the
So
time
actually
time.
it's time cycle. Huh? And what is this bread type?
Again, trigger will be patient.
Huh?
Your
Cycle, the flow, the what do you call that? The limit. Limit is again pressure
Pressure.
because it is set pressure limit. Set pressure limit. And cycling is flow because you see what has happened here. It is cut off at 25%. How is it going from expression? Expression is going by flow cycling. So what is this breath type? This is SIMV pressure controlled. The mandatory breath are pressure controlled because it is pressure. Whereas the other breath plus the second breath plus is pressure support. So SIMV pressure controlled plus pressure support. SIMV pressure control plus pressure support. Clear? Clear on that? Huh? And this is what is CPAP. Now tell me about CPAP. Mega, can you tell me about CPAP? What's happening here? What is the trigger? Patient triggered, yes. Because you can there is no trigger. Is there a trigger here? There is no is the ventilator delivering any support here? It's not delivering a breath. So you don't talk about trigger. Okay. Here patient is breathing. Limit. Again no limit. Cycling. No cycle. All that the ventilator is doing is giving a pressure. A baseline pressure. In that baseline pressure, it is breathing up and down, breathing up and down, breathing up and down. This is CPAP. You see the volumes, they are what you see normally otherwise, nothing different. Clear? CPAP clear on this? Huh? Alright. So now that you've understood this much, you've understood this much?
Yes.
Now we're going to go to something more exciting, okay? We're going to do the waveforms, how our waveforms look like, so that you understand on real time how it looks, okay? How do I get this off? Alright, so this is another PPT. Ventilator, real time. What is happening on a ventilator? You see whether this is coming properly. I think you should take it in hand and take it. Okay? Huh? So now this is our ventilator. This is our regular ventilator that we're using. I've done this so that you understand what we're doing with our machines. I've done this at this point is specifically to understand all these waveforms, all these breath delivery types. Whatever we have discussed now is on the machine. Whatever machine that we are using is having the same waveform. So now you understand what is happening. We discussed we have three waveforms. We had the pressure waveform, we had the flow waveform, and you have the volume waveform. Right? This is what we discussed. Right? Clear? So if you look at it, which is the pressure waveform, Vidya?
So,
The first one. Which is the flow waveform?
flow is the second.
Second. And the
This is volume.
volume. So if you see volumes are in points. 0.2, 0.3, 0.4, 0.5, 1 liter. If you see the flow, it's in 10, 20, 25, 50, 75, 100, which can be changed. And your pressures in millimeters of mercury. You see this millibar. Right? Centimeters of water basically. Alright. Clear on this? Millibars. Clear on this till now? Am I clear? So what have I done here in this ventilator? I have set a tidal volume of 520. Okay, I have set a certain I ratio, 1:2.5. How do I get I ratio on ventilators? You press this and you get your I ratio. You have frequency and you have peak. This is what I've set. What I'm seeing over here, characteristic, I'm giving tidal volume of 520, giving tidal volume of 520, giving tidal volume of 520. That's the volume is constant. The volume is constant. Right? Clear on this? Volume is constant. What am I doing? I'm actually giving an I ratio 1:2.5. That's why my flow is cutting off at 1:2.5. So if, for example, if frequency is 12, what is my breath cycle?
5 seconds.
5 seconds. Wow. How? 60 divided by 12. 5 seconds. So in that I put 1:2.5. In that 5 seconds, 1 is inspiration, 2.5% is expiration. That is my ratio. So my 1 will be say 2, say 1.5 or something, and the next would be expiration. Clear on this much? Clear on this much? So what is happening over here? My inspiration is starting. Okay, my inspiration is starting. It's gone up. It's gone up. And you see right over here, the flow is cutting off. And it's dropping down. Until here, it remains constant. And then it is starting the expiration. So there is an inspiration. The phase comes up to here. But actual blood delivery is stopping somewhere here. You understand? So inspiration, expiration. Clear? Expression is going right from here till this part. Time. Clear? Huh? Clear on this? So this is how the ventilator looks, isn't it? See this? This is exactly how it looks.
So this is complete control.
So whatever control mode, because I cannot see on the waveform and understand this. But I can, how I can make a judgment, is this control mode, yes or no? What is happening? If the patient doesn't trigger, it is controlled. So there is, let's go back to this. Your frequency is 12, total frequency, F total is 12. You have said 12. That means patient is not triggering any breath. That is the estimate. What you are seeing over here, frequency 12, that means most probably patient is not triggering any breath here. You understand? And volume is constant. Volume is maintained and constant. Okay, clear? So in this, when I go back to this kind of mode, what I'm seeing here is pressure versus time, flow versus time, and volume versus time. Clear on this? This is basic. Now we'll come to all of those breath types now. Okay. Now look at this. Okay. Now you have this pressure type. Let's go to the pressure type and see what this looks like. All right. This is the pressure, right? What I'm seeing over here, the topmost part is my peak pressure, 22. The topmost part that I'm seeing here is my peak pressure. I have a pause in the middle, that is my plateau pressure. Clear on this till now? What I'm seeing my peak pressure? Right? Clear? Pressure. This is my inspiration. This is my inspiration. This entire part is my expiration. The entire part is my expiration. Okay. If I would divide this line, it is like this. So you have an inspiration, you have an expiration. See where the expiration is cutting off from the flow waveform. See this. The expiration is cutting off the flow waveform right here. Breath delivery stops right here. It is stopping right here. And that's where exactly where your volume also is cutting off. Understanding this? Clear on this? Inspiration. And that's your expiration. 1:2.5, which we had said. Clear? So you must remember this waveforms like the way it is, because this is the physiology of the breathing in your mechanical ventilation. Right? Now, I'm going to convert from volume control to pressure control. Okay, we discussed what volume control was. What is volume control? Trigger is, can be patient or can be machine if it's assist volume control. Limit is volume. Cycling is time. What is pressure control breath?
Patient or machine triggered.
Or can be any of these two.
Then limit is the pressure and cycled by the flow.
Cycled by pressure control.
And time.
Time and variable is?
Variable is volume.
Whereas volume variable there was pressure. Okay, so let's do that. Okay, so what kind of breath is this? See, look at this. Look at this. Pressure going up, coming down. Pressure going up, coming down. Can you see pressure going up, coming down? Flow remaining constant. So this is volume control mode. Flow remaining constant. Volume remaining. Now I am converting from pressure control to volume. See, convert to pressure control. What has happened? Suddenly. Did you see what has happened suddenly? What has happened suddenly? What is the change that you have seen?
The cycle.
What is the change that you are seeing?
Flow graph.
Go back again. Let us do it again. Okay. So see carefully and tell me what is happening. Okay, we are starting the whole thing again.
So this is volume control.
Okay. Cover pressure control. What is exactly happening in the graph? Tell me the difference in both the graphs. Okay. What has happened?
So then when it reaches a certain
So what is happening here? It has reached, the control has changed. Till now the limit has changed. The limit was initially, this was all varying, right? The limit has changed. So it has become pressure controlled graph. Okay. And even the flow wave characteristic has changed. It was constant flow. It has become decelerating flow waveform. Clear? And it has cut off here. It is not pressure support. Initially we thought flow cycle died. No, it is still time cycle. It is cutting at the same time. It is cutting at the same time. It's only that the flow is not finishing. Are you understanding? It is only that the flow is not. Remember this once more. See, this is your time. You have put the set this. You have set an I ratio here. I ratio is constant. Okay, I have set an I ratio here. So this is my expiration. My expiration is starting right here, right? My expiration is starting right here. It's starting right here expiration. Now let's see what happens to the pressure waveform. Tak karke expiration will remain the same only. You understand? It has remained the same only. The expressions remain the same only. It's only that it is not decayed completely. Clear? Your expiration is short. Now it's long. If I were to actually increase my inspiration, you will find this falling down. Because it has to maintain this pressure, it is coming and cutting off here. समझ में आ रहा है? Clear on this? So don't look at the flow characteristic and say it is flow cycled here. It is still time cycled. Clear? That is the pressure control, right? Huh? So see how it changes now. Both are kept side by side. Okay, so this is volume control. On the right there is volume control mode of ventilation. IPPV in this machine is called IPPV. Okay, the same IPPV here is pressure controlled. It is also IPPV only, but it is pressure controlled. See, the name doesn't make a difference. You understand? It is the flow characteristic. It is the device, the mechanical thread characteristic that makes a difference. So the difference? Clear? Clear? Understood this? So volume control and pressure control.
So in volume control, we need to apply inspiratory pause.
No, you don't need to. You don't need to. I have just put it so that you understand what is happening to the breath when it is going from to understand cycling. I am making you understand cycling. So the cycling is not here. The cycling is here. Otherwise you will wonder cycling should be, this should be cycling. It's going from inspiration. No, it's not. This is the entire phase is inspiration. This entire phase is inspiration and expiration starts right over here. You understand? So the inspiratory phase, breath delivery has stopped, but it has not cycled yet. It is cycling right here. You understand? Inspiratory phase, it has not cycled yet. To cycle, it has to move from inspiratory phase to expiratory phase. And now it is moving from inspiratory to expiratory right here. I put that pause to make you understand how cycling is different from on the waveform. Are you understanding? So in short, if you want to really understand what cycling is going on, you have to plot this part. That's why I put that line there. So if you plot this part, or you start where the expiration is starting, where the expiration downward is starting, that is where your expiratory phase is starting or cycling is occurring. Clear? That's the difference. All right. So if I were to actually plot it, what happens in bronchospasm? Now see, what is happening in bronchospasm? Okay, this is the same patient. Okay, this is bronchospasm. What is occurring here? Can you tell me what is occurring here?
Flow is prolonged.
Yeah, so what you're seeing, first what is happening to the, no, you have to look at everything. What is happening? What is happening to the volume? First tell me what is happening to the volume. Is the volume constant? Volume is constant, right? You are getting the same volume. Getting the same volume. Volume is constant. What is happening to the pressure suddenly? Peak pressures have gone very, very high. That's why variable is pressure. Variable is pressure. Peak pressures are going very, very high. Plateau is living right down there. The peak pressures are denoting your pressure in the airway, whereas plateau pressure is denoting the pressure in the alveoli. So the alveolar pressure is remaining low, the peak pressure is going high. Now because there is the expiration is the patient process, okay, the expiratory phase is extremely long. Okay, not only that, your peak expiratory flow rate, see how where it has reached. You understand? Your peak expiratory flow rate has become smaller. Not only that, the flow is not reaching the baseline. The flow is not reaching the baseline. The flow still has a small blip over here, which is basically dynamic hyperinflation. Clear? Alright. So you see the difference? Here flow is reaching the baseline. Here flow is not reaching the baseline. Before it reaches the baseline, the next breath is starting. Before it reaches the baseline, the next breath is starting. The pressures are changing. Peak pressures, peak expiratory flow rates are changing. Right? This is what you're going to see. So when you are going to tomorrow ventilate put the patient on nebulizer, you should be looking at this characteristic of this peak expiratory flow. What is happening to that? What is happening to my peak pressures? You are supposed to look at it. Otherwise, you will not know how much to nebulize. You will not know how much to nebulize. So when you are nebulizing a patient, what is happening to my peak pressure? What is happening to my flow? What is happening to my peak expiratory flow? You are supposed to see that. And what is happening to my patient? Clear? Right?
So this is not auto peep, no?
Same. So auto peep is basically a number that we get as pressure, and dynamic hyperinflation can also be used as auto peep, but however dynamic hyperinflation is the patient is unable to trigger the breath. it is dynamically hyperinflating. Huh? So pressure is a number, whereas dynamic hyperinflation is a process. The both can be used colloquially, but it's not the same. You understand? It can be the dynamic hyperinflation, autopeep can be used the same, but autopeep is a number. Whereas dynamic hyperinflation is a process that is occurring inside the body. Are you understanding? Huh?
So this is dynamic hyperinflation automatically generated.
Yes. Dynamic hyperinflation causes autopeep. Use it. Use whatever you want. You can call it as. Clear? Huh? Now look at air. So you have set a tidal volume. Okay, this is IPPV. It's called as IPPV here because you set a tidal volume, volume control. You have set a frequency. You have set an I ratio. Now what is happening over here? There is an inspiration, expiration coming in. Okay. Now let me just show this again to you. All right. Oh God, it's not there. See this? What is happening? It had given a pressure, but the patient requires more. The patient requires more, so it is pulling, but getting the same flow. Flow is not changing. Flow remains the same. But what is happening? Patient is pulling. So when the pressure has gone up, okay, because this is volume control mode of ventilation, flow does not change. Since flow does not change, patient is trying to pull, flow remains like the way you have set it. Flow remains like the way you have set it. But what is changing is your pressure. This is air hunger. You understand? Because it's volume controlled. You understand? The volume remains the same. You can't change the. If I show the volume waveform, it remains the same. Are you understanding? So in air hunger, in COPD patients, what can occur? So when you have a patient on COPD and you have pressure, you have volume and you have flow, flow is constant in IPPV. Flow is constant. Patient is taking more. He wants more. Is he getting more flow? Because it is constant. What is changing? Pressure. And that's what you have to find out when you're looking at your pressure, flow and time waveforms. Clear on this? Huh? Want to see this once more?
So in the GE machines, when we get that negative
On pressure, So it should be negative on pressure and flow should be constant. That is air hunger. You understand? Huh? So if you look at this again, see what's happening? Can you see this? Huh? See, this is normal. Okay, and now let's see what happens. The patient will take a breath. Oh, see that? Okay, it's taken one excess breath. It was breathing but wants more. So it took one more. You got the point? Huh? This is called as air hunger. Clear? It's called as air hunger. Clearly you can see air hunger. Okay? That's air hunger. Right? Air hunger. Right? Huh? You can see he's also breathing in the middle here, breathing over middle here, breathing over middle here, but ventilator is not here. Right? Huh? It is not able to take it. Okay, now we did this is broncho constriction, we did discuss the fact that the flow was not reaching the baseline. This is exactly that only. Can you see that? Huh? The flow is not reaching the baseline. This is called flow restriction. So on the waveform you should say this flow restriction happening. And you can see this flow restriction that's happening. Right? Peak pressures may go up. Flow restriction is happening. This will lead to pent up of pressures in the body. Reduction in, last time we did do heart-lung interactions. It will reduce the venous return and patient can have a cardiac arrest. Okay, so that is why in these cases when you see excessive flow restriction and the BP is dropping, the first thing you do is disconnect the ventilator or change the mode, which you should have done last time. You had called me saying, sir, BP drop or BP drop or your thinking should have been, am I reducing my venous return? Which you were reducing. We changed the mode and what really occurred? The BP came out. You should have thought like that. Huh? Flow restriction. Okay? Clear on this? Clear flow restriction? Huh? So this is what is happening over here is flow restriction is happening. What I have done over here, I have changed my inspiratory time here, 1.8, 0.7. When I change my inspiration time, I increase my expiratory wave, increase my time for expiration. Since I changed my time for expiration, my flow restriction reduced. What did I do? I removed the inspiratory pause. What I have done here, there was inspiratory pause here. That was eating up my expiratory time. It was eating my expiratory time. The whole inspiration was still here and expiration was only this much. Now what do? I cancelled off that inspiratory pause by altering my ventilator here. See, I altered my ventilator by changing my I ratio. So once I changed my I ratio, I just brought my inspiration from here to here. That is my expiratory cycling I started here. When I started my expiratory cycling right over here, I had a longer time for expiration, which thus allowed this patient to unload. Right? So flow restriction just moved off. The flow restriction just moved off. Clear of this? Huh? Flow restriction just moved off. Of course, there has been no response to bronchodilator because the flow characteristics remains the same. Bronchodilator has not changed. You understand? Huh? Now look at how when bronchodilator, how am I seeing the patient? This is my this was what it was, and as I am treating it, look at the flow waveform. It is improving. Can you see? The flow waveform is improving. Flow restriction was there. Okay, flow restriction was there. Like for example, look at this, how it has improved. It has improved. It has reached the end. It has reached the end, which was not the situation over here. You understand? See, this is flow restriction, and then when I treat it, my flow restriction moves off. I change, whatever I did, it has helped. Now look at what happens in ARDS. ARDS is not so simple. When I look at ARDS and I'm doing volume control mode of ventilation, it is not simple. Okay, so what happens now? This is the start. There's a patient who came in, 60-year-old, say for example, who comes in with ARDS. He's breathing at a rate of 30, 25 or something, 35 or something. Full lung is full of problems, and you decided he's a big guy, 70 kilos, okay, 70, 80 kilos, 6 feet, okay, and you found that this patient is definitely not okay. I need to intubate, ventilate. I intubated, ventilated, and put this patient on the mode that I know best. The mode that I know best is volume control. Okay, so I don't need to do a specific mode to improve prognosis of any patient, because I will do the mode that I know best, and the mode that I know best is volume control mode. So I have now taken this patient of ARDS and put him on volume control. Are there any problems that you can see with here? So this is my setting. This is our ventilator, IPPV. Are there any problems that you can see in this patient? So this is the mode that was set by Supriya some time ago, and you came in your over and you saw this. Do you think that there is any problem?
Peak pressures are elevated.
Uh,
Along with the plateau pressures.
what is my problem? First, find my major problem.
Tidal only.
Yeah, the first thing is my tidal volume, isn't it? My first thing that I know for certain in ARDS is I have to give low tidal volume ventilation. That is my first thing. So what is the tidal volume here? Isn't this really high? Even if it is 70 kilo individual, predicted body weight is say 72 or 68 for that matter. Is my tidal volume high? It's very high. Even if I catch 8 ml a kilogram, 8 6 is 480 ml. What we're seeing over here is? Right? 833. So definitely that is a problem. Right? So what do I do? So let me start ventilating this patient. So I started ventilating my patient. Okay? I found that the first biggest problem that Supriya has created here is to actually increase my tidal volume. Okay? So you come, no, let me reduce my tidal volume. Okay? So the first thing that she does is she reduce the tidal volume, and she got it to 560. 560. Now, what are you waiting for? You are waiting for this minute ventilation to settle down. Okay? So now at 560 and 9, my minute ventilation is going to settle down as a product of these two. 6 9s are 54, 5 9s are 45, 5 liters approx. It should come to 540 or something. So it has to settle down. Okay, it's settling down. My minute ventilation is settling down. Needless to say, what are the changes that has occurred when I reduce my pressures, when I reduce my volumes? Is my pressure coming down? Okay, 33 it was, it has come down to 26. You see, my peak pressures has immediately come down. My flow characteristics have suddenly become higher. Okay, it is changed. Flow characteristics. So it's reaching its denomination that we thought. Okay, 5.35, 5.3, 5.26. Okay, now my peak pressures are 48. It was very high, it's come down. Okay, this is mean airway pressures. Okay, that is a mean airway pressure. Alright, so it has come down to 5.03, 5.02, 5 liters. Okay, 5 liters, come to 5 liters, 4.9. Okay, but of course I can't leave it at 4.9 because there is going to be ETCO2 retention here. So I am going to increase my RR, that is low tidal volume and fast RR. I want to get to 6 to 8 liters. I can't leave it at 4. 4 is too low, 3 and 4 is too low. I want to reach 6 liters or 5 or 6 or 7, something higher than that, 6 liters, 8 liters. So I increase it to 14. So as I increase to 14, what is going to happen? My tidal minute ventilation again going up. I first reduced my tidal volume, and the second thing is I increased my respiratory rate. Okay, so it is now going up. Alright, it is now going up 6.19, and as I have increased my RR, what has happened to the expiratory time? It has actually reduced. My expiratory time is actually reduced. Okay, as time is going. Okay, 6, 7. I reached my minute ventilation. I want to set it at 7 to 8 liters, right? So I am reaching 7 to 8 liters. Okay, I have reached 7.34. Now my problem over here is I have to further reduce it. Okay, because it is 580 is also high up. So I'm coming to 490 and I'm looking what is happening to my minute ventilation is coming down, right? Now look at my plateau pressure. I want to reduce my plateau pressure. My plateau pressure is still 30. I want to get it lower. I've reduced my tidal volume. I've got my plateau pressure 30 because that was what I wanted to do. My plateau pressure has come to 30. I want to get it even more lower. 25 is better than 30. Okay, so I'm at 30, but my minute ventilation is going down. It is going down. It is going below that. So I will reduce it further. I'm making it 400 maybe. Okay, so 420. My total 5.88 is this is going higher. My minute ventilation is now going to go lower, and my plateau pressure has come back to 26. So how much time it is taking for me to get one parameter in control? I'm showing you. Okay, this is real time. Okay, so my parameter coming under control 26. Okay, now it has come to 26. It's not yet. It's come to 26. What I'm seeing is inspiration, very large expiratory time. Very large expiratory time. From very small expiratory time, but the inspiratory phase is very large. I'm getting a plateau pressure of 26. All right. So we are coming down on the minute ventilation. It's now again going lower than 6 liters. It's going lower and lower. We are obviously taking some permissive hypercapnia here. Okay, so plateau pressure has come to 26. It's acceptable for me that my plateau pressure comes to 26, and even low, I would be happy to take it even more lower than that. Okay, so 5.8, 5.7, let us see where it comes and settles. So what I'm trying to tell you is don't just set and go. Set and see. Set and see, because it takes time. Okay, of course, I will need to change my frequency. Okay, because of the fact that it has gone low. I need to go above 6, okay, or I achieve my I ratio has become 1:1. When I did this, automatically my I ratio became 1:1. It was 1:2. That is why I showed you the inspiratory time, expiratory time. It has become 1:1. Of course, I don't want to keep 1:1 because it will cause problems of flow restriction to me. So I'm going up on that. I changed my I ratio again. So I touched my RR, and what changed? My I ratio. When I touched my RR, what changed was my I ratio. So you should think that I'm touching a RR, but my I ratio is changing. Okay, so my I ratio changed. So now I want to improve oxygenation. The way I can improve oxygenation is by actually getting more blackness on the screen, getting more black. So this was lower black, I made it higher black. You understand? On the screen, this is my mean airway pressure. So as I'm going up, my mean airway pressure will keep changing. Okay, so my mean airway pressure is going up, and as my mean airway pressure is going to see, I made it 1:1, even more blackness. From 1:2, I made it 1:1, even more blackness. It was cutting over here. Now it is cutting over here. So even more blackness. So oxygenation is further improving. Are you understanding? So more blackness means more oxygenation. Are you understanding? More blackness means more oxygenation. So I made it 1:1. I have more oxygen. ARDS patient, I want to improve my oxygenation. This is what is occurring. I am looking at this. Okay. Now, what is my ratio? This is my tidal volume 420, and I feel maybe I need to reduce it further. Okay, I need to reduce it further because obviously my plateau pressure has gone up because I changed my I ratio. See what is happening? I just changed my I ratio. What happened to my plateau pressure? It went up. You understand? So when I can't keep it 34 and 33 and 32. I want to come down on it. So I had to reduce my tidal volume. There is no other option. I reduce my tidal volume. Obviously, some amount of hypercapnia I will accept now here. Okay, I have got to 6.46. I have my peak pressures to be 45. I have my plateau at 30. I want to reduce it further. As I told you, I am happy with lower. So I am coming lower to 380. When I come to 380, I am now setting the 380 and seeing what is happening to my minute ventilation. In fact, 370 I got it. Okay, I got to 370 and I am checking what is happening. Okay, so I am checking mean pressures are 27. My plateau pressures are around 29 now, going down. 29. I have achieved this kind of plateau pressures. Minute ventilation is achieved. I think I want to reduce it further because I want to reach a lower tidal volume. Okay, when I say 4 ml or 6 ml, and I want to be somewhere around 350, 380, so I come to 350. And as I come to 350, my plateau pressure is changing. My ventilation is going down. It is going down to less than 5. What I need to do? Increase my RR. So let us see what happens. Okay. So I will have to increase you. Look at this. One ARDS ventilation setting. Look at the amount of changes that we are doing. Look at the amount of changes we are doing to improve oxygenation. Okay. I increase my RR is there. It is 1:1 as of now. Okay. Now I'm going to increase my RR because my minute ventilation has gone low. I made it 17. Okay. I made it 17. I have more blackness. I don't see flow restriction. my inspiration expiration ratio is 1:1 most probably. Alright, 1:1. My plateau pressures are 28, my peak pressures are 48. I want to increase my minute ventilation further because minute ventilation is lower, it is 5 liters. I am increasing minute ventilation. At the same time when I am doing that, I am going back to my I ratio and setting this again. Because every time I am changing my RR, my I ratio keeps on changing. So again I have to go back and make it 1:1, otherwise it will become markedly inverse, 1.5:1. You saw that it happened 1.5:1. So when I am setting my RR, I am going back to my I ratio. Now I have got minute ventilation that is going up. I have got a setting of a tidal volume of 350 which is acceptable. I have got an RR that is there at 20. I got an I ratio that is acceptable. And I have a plateau pressure that has come as 28. So see how long it takes. How long it takes for setting a ventilator. How long? Can you do this in a second or 1 minute or 2 minutes? It is impossible. If you don't put these readings on your screen, then it is possible. If you don't put these readings on the screen, it is possible to do whatever you want to do. You don't understand the numbers, you can do what you want to do. You don't touch the buttons, you will not understand only what is happening. Are you understanding? Why we are understood this? Because we touch the buttons. You understand? If you don't touch the buttons, your RR change would have caused catastrophe. Are you understanding? So what I told in the last 4 minutes, 5 minutes or almost 4 minutes, this is me doing it, okay, so it's very fast. Okay, so in 3.5 to 4 minutes it took me just to set the patient on ARDS ventilation. So is it possible for you to just put a tidal volume on RR and leave it? It's impossible. It is impossible because you have, that is why 3-4 things learnings from here. Number 1 is the fact that you should have these values on the left of your screen when you have ARDS. You should have minute ventilation. You should have plateau pressure. You should have P peak. This has to be there on your screen. Okay. You should know how to monitor your I ratio. You should know. What you must know, when I change my tidal volume, make it lower, my plateau pressure goes lower. When I increase my minute ventilation, when I do that, my minute ventilation is going to reduce. I must also know that my I ratio is going to change every time I change my RR. Unless you press a button on the trigger called as I constant. So there is a button on the ventilator called as I constant. When you press this button, whatever you set, whatever RR you change, the I ratio will remain the same. So if I press this button, the thing that will disappear from here is this. If I press this button, this will disappear. Are you understanding? Flow and all this will disappear. You understand? Because you have set it. These both will disappear. Okay.
So the T inspiration it is?
The time in which it is inspiring. Right? But these both will disappear once you set the I ratio. Right? Because I you have made as constant. So if you set 1:2 as constant, it will remain like that only. This flow will go only. Because flow will change automatically. The flow will change automatically. If you don't have it, if you don't press this button, you have to change it to make the I ratio okay. Right? Clear of this? You understood what is the I constant there? This is a feature of some. So each ventilator has got its specific features. Okay, this is one of the features of the Drago where you have the I constant over there. Clear?
Sir, by just pressing that I constant, setting suppose inverse ratio or 1:1, whatever, for ARDS triangle, we need not do flow and other changes. No?
Yeah, but why you want all these things is, what sometimes occurs is, when you keep the I to be constant, no? You keep I to be constant, and as you are reducing your tidal volumes, your peak pressures and plateau pressures might change. You are not confident seeing a 50 peak pressure. I want the peak pressure to be on the lower side, so I want to change my flow a little bit. That is dependent on you, what you want to do. How you use the ventilator for your satisfaction is dependent on you. You understand? But you must understand there are certain features on this ventilator that will probably help you out. That's all. All ventilators will not have these features. You understand? You may want to put the I constant, but I must know, I have to see my peak pressures, I have to see my plateau pressures. You understand? My flow characteristics may change, resistance will increase. So in short, if I keep my I constant and I increase my RR, my inspiration will reduce, my flow will increase. When my flow increases, what is going to happen is there is going to be more amount of resistance in the airways because flow is increasing. And more resistance in the airways means more bronchospasm if it is bronchospastic case. So these are things that you will pick up. So, clear? So increasing the blackness increasing the blackness means increasing this mean error pressure. Means increasing mean error pressure is improving your oxygenation. So to increase my blackness, I can increase my tidal volume, but I know large tidal volume will cause problem. So that's why in an ambu bag, when you press and press and press, you are actually increasing the blackness inside. You are increasing the amount of tidal volume because you're giving 1 liter. Oxygenation is going to improve, but you are causing huge amount of damage. Right? So I can increase my tidal volume. First thing. Second thing, what I can do, I can increase my pressures. If I increase my pressure, this will go up. When my pressures go up, again blackness is improving. Third thing, what I can do. So first thing I said tidal volume. Of course, I don't want to do that. Second thing, what I did, actually I increased my PEEP. So since I am increasing my PEEP, my mean error pressures are increasing. Since my PEEP is going higher and higher, more blackness is coming. Third thing, what I can do. Okay. So what I will do is, I will increase my inspiration. No, my blackness is increased only in my inspiration. My blackness is increased only in my inspiration. Right. So I will increase my inspiration. That is why when you go from 1:3 to 1:2 to 1:1 to 2:1, my oxygenation is improving. You understand? Because my pressure in my airway is remaining high for a longer period of time. My pressure inside, my positive pressure inside my airway is remaining high for a longer period of time. You understand? Clear? So these are the maneuvers that we are using to improve my oxygenation. Clear? Any doubts?
So the way we have target of plateau pressure in IRDS management, is there any target for P mean?
No, for P mean, no. So, but you can see that when you are increasing your mean pressures are going up. You can see that कि my mean pressure going up. Good, my mean pressure is going up. I want to see that कि मैं कुछ भी कर रहा हूँ, मेरा mean pressure change हो रहा है कि नहीं हो रहा है. Because there is a possibility you change your RR, your I ratio is changing. Because of which the mean pressure is not going up. You understanding? So that gives you a kind of an estimate. Oh, this is my mean pressure going up. It's okay. It's good. Whatever I'm doing, I might just change my I ratio, but nothing is happening because I changed my RR. My mean pressure is the same only. It's not going to improve my oxygenation. You understand? So I want to look at that. I want to look at. Obviously, I don't want to go to a mean pressure of 30 and 35 because that is harmful. That is harmful. 35 and all is harmful. I don't want to go to that pressures. Are you understanding? I don't want to go to that pressures because it is harmful. Right? I know the harm is lesser when it is much lower than 30. Clear? So ARDS ventilation not easy. Not easy at all. Okay. Importance, what have you understood from all these things, Amit? What have you understood in ARDS ventilation? What have you understood? What I need to maintain on my left side, what I must see on my left side?
Pressure, peak pressure.
I want to see my most important plateau pressure. I want to see my minute ventilation because that keeps on changing. Minute ventilation keeps on changing. Third thing, what I want to see? My airway pressure, mean airway pressure. And fourth thing, what I want to see? I want to see my frequency total. Because we are not paralyzing our patients. What if he is breathing faster? Everything goes for a toss for me. I need my frequency total. Okay, I need to give him a level of sedation that makes him comfortable. If I do all these things and make him breathe at 40 when I'm giving 20, what is the point? My characteristics is not changing. You understand? I want him to be in such a way that he's breathing comfortably, synchronizing with the ventilator, such that my mean airway pressures are doing what it's supposed to do. My airway pressure is doing what it's supposed to do, right? So these are the things I will look here. The other thing that I must remember is, whenever I am touching any button on the machine, I have to see the alterations that are occurring in these numbers that I just now explained to you. Okay, these numbers that I explained to you, and at the same time, what is happening to my other numbers the moment I touch. So press every button. Okay, press every button. You may want to do it this way, or you may want to. So when I say press, you may want to do it this way, or you may want to do it this way. But you have to have that in your hand. Okay, I'm going to press this, then go press this, then go press this, go press this. I'm going to do that. I'm not going to not press any number. Not leave any number unpressed. I have to press each and every number to understand what is happening. If you don't press it, you're making a mistake. If you don't press it, you're making a mistake, clear mistake. So if a person has just set the ventilator and gone, it doesn't make any sense of it. If you set the ventilator, means you're standing with the ventilator. This is the time, especially after intubation, where you are getting to completely understand the lung. Okay, this is the time where you completely understand the lung, because you have just paralyzed your patient. In that paralysis, you have done plateau pressures, you have done compliance, you have done resistance of airways, you are doing driving pressures, and you're seeing the rest of the machine parameters. You understand? So the time you ventilate your patient, you don't pat your back and put a tube through the airway. You just started your work actually. You have started looking at what is happening inside the lungs, because later on, as time goes, you want to come back and see, okay, what has happened to my compliance? Okay, what has happened to my oxygenation? What has happened to my entire plateau pressures? That is what you're going to come and see, isn't it? Because as time goes, those areas that were kind of collapsed are slowly going to open up. When they're going to open up, the compliance is going to change. When my compliance is going to change, my tidal volumes need to change, my plateau pressures are coming lower, I can make it more comfortable for the patient, I can keep it less injurious, and accordingly change parameters. I don't need to be at that 1:1 non-physiological inspiration expiration, because he's improving. So when you come back, you're supposed to do all these parameters. So if you started with a compliance of 10, now the compliance has gone to 15, oh, patient is improving, it's come to 20, wow, it's better. If 40 is normal, so I'm reaching say 25. Oh no, I don't need to give so much of I, let me go slow. And these changes are not done immediately. These changes are done during the course of your 12 hours. So if you have done one change at 6 o'clock, then the next change will somewhere at evening, 3, 4 o'clock, to understand, okay, what is happening. You cannot put the ventilator and leave the ventilator. That is wrong. Because you will find changes. That is what you are intending to do. Your therapy is going on. It's not just ventilating a patient, you are doing a therapy. That is why you need to come back and then again interrogate the ventilator to understand, okay, this is what is happening now. This is what I need to do. I will do, of course, this is just the ventilator. I'll at that time look at the pulse rate, BP, respiratory rate, ultrasound, look what's happening. Like for example, when we're doing recruitment, I'm doing ultrasound and seeing, what has happened to my B lines? Are my B lines going? Then that is collapse probably. Are you understanding? I'm improving some amount of collapse. Are you understanding? These are things that you should do on bedside basis, because that will give you the confidence that this machine is doing what I intended to do. You understand? If you just put the patient and just look at oxygenation, it doesn't make sense. Right? You have to do all these things. Right?
Sir,